Hey, g'day, it's Prezzo, and thanks for stopping by, and I hope you're well. Now, this is the first in a series of videos that I want to do on my home Foundry furnace. And we're going to look specifically at the fuel that I've been using to fire that furnace. And up until now, that's been LPG or propane or liquid propane gas. But I want to make the switch to diesel as a fuel. So we're going to have a closer look at the furnace as it is now, and we'll talk about the reasons why you may want to change to diesel. And then we're going to look at some of the equipment and materials and the parts that I bought to make the change. So let's get down here and have a look at the furnace. Okay, well, this is my home Foundry furnace. This is the second version of this that I've made. The first one was slightly smaller and wasn't as durable. This one here has been in use now for about 4 years, and it's still working fine. This is actually made from a cut down 45 kilogram liquid propane cylinder, and it's got a solid cast refractory on the inside. Now, I'm using a propane burner, which you can see down here, and I use a 9 kilogram liquid propane tank to fuel that burner. Now, like I say, it works great. The only problem is it can take up to half an hour to melt aluminium and nearly an hour to melt brass and copper. So I want to cut down the amount of time it takes to melt those materials, and we can do that by switching to diesel as a fuel. Now, I was prompted to do this by watching a video by a gentleman named Perry Merritt. Now, Perry is also known as S.W. Dweeb. He lives in the United States, and some time ago he made the switch from LPG or propane to diesel as a fuel. And he got in touch with me and he was sort of proposing some ideas. We discussed how it might work. But he was the one that actually made the leap and did this before me. And I've been in touch with him just recently, and I asked permission to give you a link to his video, which he said I could do. So check that out. It shows you what he did, and shows the burner working. Now, I got really enthusiastic about doing this, but I had other projects I needed to finish. And I had bought a lot of the materials and a lot of the equipment that I needed, but it's just been sitting there waiting for me to get started on this. So let's do that, and I guess the first thing we should do is discuss the pros and cons of working with both types of fuel, and then we can make an informed decision about whether it's right for you. So let's have a look at the pros and cons of liquid propane gas and diesel. Now, they're the only two that I'm comparing here. There are other fuels that can be used, like coke or charcoal, but I think for a home shop situation, LPG and diesel are probably the better choices. So LPG first. Number one, it's clean burning. If your burner is designed correctly, it should burn with a bright blue flame and it shouldn't produce any smoke or soot. It's also easy and predictable to ignite. It's capable of reaching temperatures adequate to melt aluminium and copper alloys. And it doesn't require any auxiliary equipment like pumps, blowers, or pressurized injectors. So I'll show you my burner design shortly, and it just simply burns the fuel, doesn't require any other equipment to make it run. Diesel. Now, diesel has a higher energy density than LPG, up to 60% higher. It's non-flammable as a liquid, so if you spill it anywhere in your workshop, it won't ignite with a flame or a spark. So therefore it's safer to store, and it's relatively cheap compared to LPG. So here in Australia, you can go and buy diesel at the service station for around about $2 a litre. LPG is cheaper than that, but don't forget, for LPG you will need an approved cylinder or pressure vessel to store it in, and because of the high energy density, diesel actually works out to be cheaper in the long run. Okay, so what are the downsides? Let's do LPG. So LPG is heavier than air and highly combustible as a gas or a vapor. It can cause fires and explosions if leaks occur, and if your workshop's in a basement, it can fill up with that LPG vapor, and one spark will ignite it and cause a devastating fire or explosion. It also has a lower calorific value because of its low density. Storage requires an approved pressure vessel and has to be maintained, tested or swapped, and LPG tanks are a hazard if they're overheated or subjected to impact or puncture. Right, what about diesel? Now, diesel is more difficult to ignite and manage during the burning phase. It does require atomization to burn in open air. It does require a blower to maintain optimal flame state. It can emit smoke and particulates, and spills and leaks of diesel fuel can cause an issue. Things like stains, residue and oily deposits. So there are our pros and cons, and like I say, you have to weigh up the pros and cons of each of those fuels and make the decision about which is best for you. My sort of experience is that it's probably better to start with LPG because the burners are much easier to construct and you get some experience with foundry work. But if you want to reach those higher temperatures or melt the materials quicker, then I think diesel is the better bet. Now, there are some criteria I want to include in the design of this burner. Now, the first one is I want it to be as safe as possible. I want it to be as quiet as possible. I want it to be lit very easily. And I don't want it to require a compressor or a source of compressed air to be able to get the burner to operate efficiently. And finally, I want it to be able to be disconnected from the furnace. So at the moment with the propane burner, it just slides out and I can put the cylinder and the burner away separately and the furnace away separately. And I want to do the same with the diesel burner. Now, propane or LPG is very easy to ignite because it is so flammable, and in the case of my burner, all I need to do is turn on the main cylinder valve. I use a small butane torch and I'll put that through the port on the side of the furnace and the gas ignites very easily and very readily. So let's try that. So as you can see, that flame burns very readily. There's no soot, there's no smoke. It burns with a bright blue flame and it will easily heat that furnace, although it tends to be slow. So the reason I want to go to diesel, I just want to reduce the amount of time it takes to melt the common materials that I use, which are aluminium, brass and copper alloys. Now, diesel can be problematic, it's hard to light, and we're going to go over to the bench now and we'll look at some of the reasons why that happens and also how we get around that. So I've got some diesel fuel here in a small stainless steel container. I'm going to try to ignite this, so I'm just going to use my butane torch. And you can see that it doesn't light up straight away. Now, if that were petrol or kerosene, that would be burning by now. Now, you can make it burn. What you need to do is heat the surface until the fuel starts to vaporize and the vapor will burn. So let's try that. I can smell the vapor now, and you can just start to see the flame, and that will now continue to burn. And the white vapor you can see there now will reignite very easily. So the problem with diesel fuel in this situation is that we've got a relatively small surface area in comparison to the volume of fuel. Now, in order to make that burn readily and light easily, you need it the other way around. So we need a massive surface area, very, very tiny volume. And the way we do that is we atomize the fuel. So this is the nozzle I purchased on eBay to try to atomize the fuel for our furnace. Now, these are sold for home heaters, the type that use liquid fuel, and the brand is Steinen, S-T-E-I-N-E-N. And on the cap here it says 2.5 and 60 degrees. Now, the 2.5 is 2.5 gallons per hour, and the 60 degrees is the conical spray pattern that nozzle will form. Now, this is all made of stainless steel except for this back section here, and it's got a very fine gauze filter on it with a brass back plate, and that gauze is to stop any impurities that might clog that very, very fine jet. Now, in order for this to produce those tiny, tiny droplets that will ignite easily, we need to pressurize the fuel. So let's have a look at the pump that I've got for that. So here's the pump. Now, this was sold as a fuel pump for a Yamaha motorcycle. And this type of pump here runs on 12 volts and it's submerged in the fuel tank itself. There's a fine filter which goes on the inlet. There it is there. That just simply clips onto that inlet there. And this is the outlet here. Now, runs on 12 volt DC, so it's sort of safe-ish. I don't imagine there's going to be any issue with this submerged in fuel and sparks, so I don't think that's going to become a problem with diesel. Not so sure about petrol though. So I haven't actually tried this yet. I need to make up some fittings to connect the actual burner nozzle to the pump, and then we can try it out and see how much of a spray pattern we get. Now, if you want to burn a lot of diesel fuel, you're also going to need a lot of air, and one way around that is to use something like a leaf blower, but those things are incredibly noisy, and I actually had one and I tried it out, but one of the criteria that I set for this burner was that it should be as quiet as possible. So I ended up buying this. Now, this is a Chinese-made blower, and it's rated at 370 watts. These were available in about 4 different sizes. I just picked somewhere in the middle. There's no indication on the label here of how much air this can produce, the volume of air, but it seems about right, and I have run it, and it's fairly quiet. Now, you do also need to regulate the amount of air going to the burner. Now, one way of doing that is to fit a flap on the inlet side of the impeller, which is on my left here, and you can open that or partially close it or fully close it, and that will restrict the amount of air going into the impeller and therefore going to your burner. Now, another way of doing it is to do it electronically, and I purchased this gadget here on eBay. It's an electronic regulator. Now, it says on the label here it's a thyristor electric voltage regulator, and it's allegedly able to adjust voltage, light, speed and temperature. Now, I've tried this out on a couple of different motors and light bulbs and that sort of thing. It seems to work great, and it wasn't expensive. So I'll just turn it on. I'll just give you some idea of how that works. Now, the digital display there is supposed to show voltage. So in Australia we're 240 volts, that's running at about half that, and my blower is nice and quiet, but it's producing a fair volume of air. Now, I'll run it up to full speed, and that's a lot of air. And you can adjust it down pretty much to nothing. So it's just ticking over there now. So I think that's going to work fairly well. The only problem is that when you restrict the airflow, the motor does increase in speed. So if I cover up the outlet, let's just turn that up a bit, and the motor slowly increases in speed. Now, that could be because there's no load on the fan or the impeller, so the motor overcompensates and runs faster. But it could make regulating the air a little bit tricky. Well, we'll just have to see how that goes. Now, what I'll probably do is deconstruct this gadget here and fit it into some sort of a console, and it will fit up above the blower and the fuel tank on a cart of some sort. And we'll have switches on there for the blower, speed control for the blower, and a switch for the fuel pump. And that way, at the end of the day, I can just sort of put that whole unit away. Now, in order to get the air into the burner, I've got this 60mm OD flexible ducting. I got this on eBay as well. It's nice and smooth on the inside there, so it doesn't restrict the airflow a lot. And it's just long enough to be able to connect that onto this 3D printed adapter here. And that will connect to the burner. And that way, I don't have to align everything. It can sit off center a little bit or sit it back away from the furnace a bit. And then I can just simply disconnect that if I need to. Now, with my old propane burner, I didn't need to worry about a blower of any sort at all, because this operates on the same principle as a Bunsen burner that you used at high school. So there's a gas jet just inside there, and these little ports on the outside here are open to the outside atmosphere. And as the jet of gas goes through the center of the burner, it draws in sufficient air to give you a nice, hot, clean blue flame. Now, I just eyeballed the size of those ports there, and I must have just got lucky and got it right, because I didn't need to adjust them at all. But you could easily put a restrictor over that so you can control the amount of air going into the flame. But like I say, I just got it right. So this doesn't need the blower, and I have seen some people using propane and a blower and using a much bigger jet, and that way you can get a hotter flame or a bigger flame by using a blower as an auxiliary air source, but I didn't worry about it. So that's where we're going with the air supply for the burner. I've just got one more thing to show you, then we need to go on and make some parts. I just partly dismantled my furnace here because I need to be able to get at this hole here. Now, ordinarily that hole would be facing this little ring adapter here, and this is where the old propane burner went through and just sat inside this ring, and it protruded inside the hole in the side of the furnace. If I turn that around there, I can show you what I'm going to use for the diesel burner. So I've got two pieces of this Schedule 40 pipe. It's 1.5 inch inside diameter, got a 4mm wall thickness, roughly, what's that, 3/16, and I've got it in two parts. Now the smaller part will fit inside this hole here. Now again, I got really lucky here. When I made this furnace, I just cut a 2-inch diameter hole in the side of it, which turns out to be a really neat fit for this Schedule 40 pipe. Now the longer section of pipe will have the fuel hose or the fuel line going into it, and the spray nozzle will be exposed on this end here, so we can tighten it up and service it and clean it and so on. And it will have some sort of a quick release or a bayonet mount so that we can push this on, twist it or lock it in some way, and then at the end of the day you can pull that off and put the whole cart and this section of the burner away. And this can just stay in there permanently. I could weld that in there with a single tack weld, but I think it's just going to stay there. So what I'm going to do is cut this ring off here. Actually, do I need to do that? Probably not. Yes, I do, because I've got to turn this around and bolt it at the top here. So I'll cut this ring off, but I'll leave the extension there so that if I ever want to use the propane burner, I can put some sort of another mechanism on there. I'll work that out later. Okay, need to go and get some parts made. That's both ends of the removable section of the burner done, and I did the other section that goes in the furnace off camera. It's the same setup. Now I need to be able to join both these sections of pipe together. So this is the burner section, and then there's the fixed section that fits into the Foundry furnace itself. And I figured the easiest way to make this demountable is to have a collar that fits over both sections of pipe. So I was able to find this material here. This is like a very heavy walled hydraulic cylinder material. It's the correct outer diameter. It's a bit small on the inside bore, but we can machine that out, bore it out on the lathe to make it fit, and then I'll fit one section by welding and the other section will have a locking screw so we can remove it. Ow. Alright, now I found out this pipe is anything but round. It's about 0.4 of a millimeter out of round. Don't know whether all Schedule 40 pipe is like that, but what I'll do is I'll just skim one end of each piece to be a nice fit in that bore there. Not too tight, I want it to be sort of loose enough so it goes together easily. If I make it too tight, it'll probably corrode itself together. Sort of see how out of round that is. Should be able to get a dimension there. That 0.4 to come off. Okay, so that's about how I want that. I'm going to do the other piece the same, and then we can work out how this joining mechanism is going to work. Now that I've got both sections of that burner tube done, I need to get on and do the fuel delivery system. And what you're looking at on the bench there now is the most of the materials that I'll need to do that. So of course we've already got our spray nozzle here. We don't need to do anything to that. But I need a rigid fuel line which will take the fuel from a flexible hose to the tip of the burner nozzle. And I found this in a car park. I think it's one of those sort of drinking straws that you can buy to replace paper straws. And I think it's stainless steel. Now I don't know what that weird color pattern is. I suspect that's just a powder coat of some sort. I don't think this is titanium, which can be anodized to give it that color pattern there. So for the moment we'll just say it's stainless steel. It's 6mm outer diameter and it's got a very thin wall. And it's already got this one bend in it, but I'll need to put a second bend to make it into a sort of a joggle shape. And in my scrap box I also found this quarter turn tapered plug valve. Now this is going to allow me to shut the fuel off completely after I'm finished with the furnace, and I can also throttle the fuel. I can sort of get a half setting on that, like a half open setting, and slowly introduce the fuel to the burner. Now I had most of the fittings I needed. I just had to make this one little barb on this end here for the flexible fuel tube, and on this end here I had to make a custom nipple which is the correct diameter for our piece of rigid tube. So that'll fit in there, and that'll be silver soldered later on. Now in order to connect the nozzle, the fuel spray nozzle, to the other end of that tube there, I need to make a fitting. And I'm going to use some round stainless steel bar stock and some hex stainless steel bar stock. And that will form the union nut, basically a replica of that. And the little nipple there, I'll make that out of brass, I think. I wanted to use stainless for the hot end because it's very close to the inside of the furnace, and I'm not sure if brass is going to be up to the task. And if that little brass nipple doesn't stand the heat, I can just take it off, make a stainless steel one. Okay, so let's head over to the lathe and let's work on these parts. That hole I just drilled there is the tapping size for the thread that we need, and this is the tap. This is a 9/16 by 24 UNEF tap, same thread that's on the fuel nozzle. So I'll go ahead and tap that now and we'll see if we can get the nozzle screw in there. There's some work that needs to be done on this end, and I need to mill a hex on that, but we'll do that as all second ops. Okay, that looks good. We may have to put a little copper washer in there, we'll see. So this can come out of the lathe now, it needs to go over the mill, so we need the hex, and then I'll flip it and we'll do the fitting at the other end. But I'll go ahead now and actually make the union nut. That hole I just drilled there is the tapping size of my thread, and the thread we're using today is 7/16 by 26. Now that's a model engineer thread, bit of an oddball size, but it's a nice fine thread pitch. It means I can keep this component fairly small. And I needed to have a flat bottom hole there. That's where the end of the nipple will seat against. And that's why I use a slot drill, or an end mill, sorry. Slot drill, end mill, whatever. There's our union nut, just needs deburring on that side there, but that's pretty much finished. Just transferred that part to a hex collet block in the mill, and we're going to cut some spanner flats on that now. Now this can go back in the lathe now, we can finish off the other end. And I'm not sure about you, but I never get consistent depth of cut when I use a hex collet block and a vise. Some of these crests got slightly more flat than others. Could be a file job there, but at least the spanner fits. Now the old rear parting tool holder is still doing its thing. Totally happy with that build. So we'll get the other end of this now machined down for the thread that will take the union nut. Okay, it's got to put the 60-degree seat in the end of that fitting there now, and it's done. Okay, that didn't go to plan. I had to use a bigger center drill and there is a bit of chatter there, but this fitting being brass will deform into that shape and there's not a lot of pressure there, so I think we're going to be okay. Well, there's all of the parts of the fuel delivery system so far, and the way this will work is our fuel valve will get silver soldered onto the end of our stainless steel fuel tube. Don't forget this is a coupling nut that can be undone here. And then at the hot end we've got our fuel nozzle, which will screw into the adapter, and then the brass nipple, stop laughing, that's what it's called, that will fit onto the back of the adapter there, and then our coupling nut will go over the top of that, and another silver soldered joint will hold the stainless steel tubing into that nipple. Stop laughing. Alright, so this will need to have a second bend in it, and the way this is going to get assembled into the burner tube is that we'll put a large hole in the side of the tube there, about 18mm diameter, and one of the reasons I wanted to be able to pull this apart was so that we could poke the finished coupling nut and fuel tube through that 18mm hole and then twist it and rotate it, and then it's going to finish up in about that position there. And then I can get at this coupling nut with a spanner and tighten everything up once it's assembled into the tube. And then to cover up that large 18mm diameter hole, I'll make some sort of a cover plate to go there. The tubing will need to have a second bend put in it with a pair of these fairly crude bending dies. These will go in the Hosfeld bender, and we can put the second bend in there without kinking the tube, I hope. And on the back end of the burner tube we'll need to assemble our 60mm flexible hose, and at the moment that's not going to fit. So I've made up this little adapter off camera. It's just a bit of heavy wall pipe, and of course that's an absolute... oh, what the f***? Okay, don't worry, I have a cunning plan. Alright, and here is the cunning plan. So what I've done here is I've added some 1.2mm nails and jammed them down into that gap, and now I've got an annular gap between the burner tube and the adapter. Now what I'm hoping here is that we can mitigate the problem of conducted heat coming through the burner tube from the hot end to the end where the blower is attached. And I'm using a little bit of jet engine technology here to help me do that. Now in jet engines what they do is they use excess air from the compressor to act as cooling air around any of the components that get really hot. So the tailpipe, the combustors and all those sorts of things have got jackets around the outside that contain that cooling air. And I'm hoping that I can blow some air through this gap here and it'll exit through the front here, and that will keep that component cool. Now I'm also going to have just 3 spot welds around there so that there's like a heat break and we won't get a lot of conducted heat going through that component. It may turn out that this doesn't conduct a lot of heat anyway because we're going to have air blowing through that pipe the whole time, and that may cool it enough to not have to worry about that. Alright, let's do the wind up. Well, that's it guys, thanks for watching today. Now in the next episode I want to finish off the burner assembly. I want to get the fuel pump at least partly assembled and connected to the burner assembly, and I'm dead keen to see what sort of spray pattern we can get from that fuel nozzle and whether that will ignite easily. And I must say this build is both exciting but also a little bit intimidating because this thing is just 2 components short of a jet engine. And what we have is a radial flow compressor, we've got a combustor, and we've got a gas generator right here. And if I was to fit a nozzle guide vane on the exit from that lid there and a free turbine, we could actually generate some horsepower. So it's actually that close to being a jet engine. So yeah, it should be exciting. So thanks for watching today, as I said, and please join me next time. This is probably going to be about a 3 or 4 part series, and I hope that you've learned something today and that you're also excited about making a partial jet engine. Okay, it's Prezzo signing off for now, and I'll see you next time. Cheers.